This video will talk about sample space and event. This is an example on page 120. So we're going to record the number of customers who use credit card or debit card. So we have 135 customers, and the sample space will be not the customers, it will be the numbers of them who use credit card. So maybe nobody used the credit card, so the answer will be 0. In this case, 0 will be in the sample space. And if one person used credit card or debit card, and then the answer will be 1, or maybe 2 people or 3 people, because we only going to survey 135 customers, and the maximum number of customers who use a card will be 135. So this is the list. This is the sample space, which listed all the possible number of people that use credit card or debit card. So notice that the sample space is not the customers. It's not like Matt or Mary or Pat. It's not the names of the customers. It's the number of the customers. How many of them used a card? So that is one way to list of all the answers. And the other way, if we want to use inequality notation, we can use this way here. And so S is the sample space. We always put curly brackets to represent the sample space or the event. So that because it's like a set. X here means the number of customers who used cards. So X first, if we use the inequality notation, we must add the sentence. X is an integer or X is a whole number, and we can add X is between 0 and 300. Actually, it's 385 customers. I'm sorry, it's 135 customers. So we have 135 customers. So X is a number between 0 and 135. But if you don't add this sentence, we may think X could be 0.5 or 0.1, and it doesn't make sense because the number of customers cannot be 0.1. We cannot have half or 1.5 customers or 0.5 customer who used credit card or debit card. So we need to specify what kind of number X is if we choose to use the inequality notation. But there are cases that, so there are 2 ways to write. You can either make a list of all the possible numbers, 0 customer, 1 customer, 2 customers, and so on, ... to if you don't want to write down 136 numbers, you can just use ... the dots, 3 dots, to represent all the numbers. So that's like a pattern. So but it doesn't mean we only have these 4 numbers, 0, 1, 2, 135. It means all the numbers from 0, all the whole numbers from 0 to 135. So this is called a discrete sample space, because if we put those numbers on the number line, so it's starting from 0, 1, 2, 3, all the way to say 135, and you can see all those dots. If I put a dot above it, each number, so 1 dot, 2 dots, another dot above 3, and another above 3, and so on, so all the way to 135. And you can see there's a gap, there's a space between each 2 dots, and that's called a discrete. Well, continuous, you won't have gap between them. So if I draw a curve, this will be continuous. There's no gap on the line. So this is called discrete. And we can look at another example for continuous. So you can use the curve, those two pictures, to help you understand which one is discrete, this one is continuous. So the example for example, if we talk about distance we travel, so right here we have say the distance you travel from now to let's say so we measure the distance of a car, a driving car, until the fuel runs out, and we record the distance. Because we don't know how much gas is in the car, so the possibility if the car does not have any gas in there, and it cannot drive at all, so the distance the car traveled will just be 0. So it will start from 0. But if it has a little bit of gas, and it can drive, say, 0.5 miles and 0.6 miles, 0.7 miles, or even 0.1 miles, 0.11 miles, 0.111 miles, 0.11111, and so on. So you can see the distance a car travel will not be just whole numbers. Well, it can be decimals, fractions, and it could be even radical numbers. So the distance, if we want to, it depends on how much gas is in the car, and the distance traveled. It could be, if we draw, so this is a real number line, and this is 0, and this is 1, and if I draw a car, all the dots, it could be 0, could be 0.1, 0.001, 0.001, and so in fact it could be any number on the line, and that is called continuous because there's no gap between any two numbers. And also we will not be able to make a list, so we cannot say, oh, all right, the first is 0 and the second is 0.1. What about the number between 0 and 0.1? We still have 0.01. Even if we list 0 and 0.01, there will still be numbers between 0 and 0.01, because we could have 0.001 and so on. So there's no way we can do the list anymore, like for discrete data. So here the only thing we can do is use the inequality. So we can say the distance a car can travel is at least 0 or bigger than 0. So x here is, if you want, you can put x where is a real number. I think it's better to do that. So x is a real number because it could be fractions, decimals, even radical numbers, and 0 is positive or 0. It cannot be the distance traveled cannot be negative. So this will be the answer. So notice that in this case we won't be able to make a list. In the discrete case, the number of people, the number of days, and it could be we use whole numbers. So it could be we could make a list, or if you want to use inequality, you have to specify this x is an integer. Otherwise, we may think x could be a decimal. Okay, so this is how we write the sample space. The next part is second question. We'll talk about an event. So event usually is just part of the sample space. So that A stands for the event that more than 50% of the customers purchase with a card. So we know we have 135 people, and times 50%, that's 67.5. But we have to take a whole number. So it's more than 67.5. That would be 68. So we may have 68 customers who used card, or 69 customers who used the card, and so on, all the way up to the maximum number of customers, 135 customers who used card. So that's the event. You can see if you look at the event and the sample space, the event space only will start, the numbers start from 68, but the whole space, the sample space, has all the possibilities from 0 to 135.